Alright, so in this section we're going to be talking about transformations of basic graphs, and because we're using the calculator so heavily I wanted to use the real deal rather than my simulation, so I want to show you exactly what a TI-84 would look like. Alright, so first I just want to point out there are going to be transformations of whatever graphs they give us, but these four up top are pretty common, and I just want to remind you hopefully or possibly teach you how to graph these. So remember, we can pull up graphs using this y equals button on our calculator, and I'll just clear whatever I have out. So let's say I wanted to graph y equals x squared. Here's my variable x, so y equals x, and then I can use the exponent key, this x squared, as a shortcut, and hit graph. And there's my parabola. And I want to remind you guys that you can use this trace function or your table function. I really like the trace function personally. So you can use this trace button in your calculator, and that allows you to type in an x value and it will give you a corresponding y value. So let me see if I can point this out a little better. So like for x equals 0, y equals 0, if I type in x equals 2 and hit enter, then y equals 4. If x equals -3, enter, then y equals 9. So you can hop around on your calculator, type in an x value, and it will give you the corresponding y value using that trace function. Okay, so that's the basic view of our y equals x squared function. I'm going to clear that out. Now if we want to graph y equals x cubed, so y equals x, and then we can use this caret key over here for any exponent, including x squared. We could have used this, but x raised to the power 3. And then if I hit graph, there's my x cubed function. So again, we can use the trace key, type in an x value, so I can see right now my cursor is at 0, 0, it passes through the origin. If x equals 2, for example, hit enter, and it gives me a y value equals 8. 2 cubed equals 8, so that makes sense. -2 for x gives me -8 for y. So you can see the cursor bouncing around and see that on your screen. For y equals square root of x, if I go back into y equals, I'll clear this out. There's your x squared button, and then over it there's a little square root key. So I'm going to access that by hitting second and x squared to pull up the square root key. And then the square root of x, I just type my x underneath, hit graph, and there's my square root of x function. I'm going to use the trace key again. It already starts at 0, 0. The square root of 0 is 0. If I type in x equals 1, I get a y value of 1. Square root of 1 is 1. If I type in x equals 4, for example, I should get 2 for my y value. The square root of 4 is 2. And there's my ordered pair 4, 2. I just want to point out, if you type in a negative value, like -4, for example, so I typed in x equals -4, and for y it's just showing nothing, and that's because negative x values are not part of my domain, right? The square root of -4 would be 2i. That's not a real number. So notice that negative x values are not part of the domain. The domain would be anything 0 or greater. So I just want to point that out. When you're using trace, if you just get nothing for your y value, that means that you've typed in an x value that's not in your domain. Alright, and then finally we have y equals absolute value of x. Clear out. So the absolute value function, you can find that under the math button on your calculator. So if you hit math, and then I'm going to scroll over to the number menu, and the very first thing I see is ABS, that stands for absolute value. So I hit enter, and on my screen it pulls up the absolute value bars, so I just put the x in there. If you have an older calculator, on your screen it'll say y sub 1 equals, and then it'll literally say ABS, and you'll see parentheses, and you just type your x in and close your parentheses over here. And absolute value functions always have this V shape, so they have this sharp corner here. So for example, absolute value of 3, if we use trace and x equals 3, gives me y equals 3 as well. But if we type in x equals -3, absolute value of -3 is also +3. So that's the ordered pair -3, 3. Okay, so having said all that, let's take a look at number 1. It says, for each pair, how has the second graph changed from the original basic graph? Circle your answer. So in your calculator, notice you've got all these y equals, so you can actually graph multiple functions at the same time, which is nice. So first I'm going to graph y equals x squared, and then I'll use the down arrow to graph y equals x squared plus 2. So y equals x squared plus 2. And just make sure that that plus 2 is big. It shouldn't be up in your exponent. So on my screen, there's my original function, y equals x squared, and then my red function is y equals x squared plus 2. So my original function looks something like this. This will be my blue function. And remember, I can use trace to identify more points. So on my red function, for example, right now you can see that my cursor is on the blue function. So if I type an x value of 0 using the trace key, it tells me y equals 0. If I use my arrows, so I can use my up arrow to get back and forth between these two functions. So now you can see that I'm on my red function. And if I use trace, and type in 0, now it's putting me at y equals 2. Oops. There we go. So it's putting me on my red function. If x equals 0, y equals 2. And I can crank out a bunch of other points as well. For x equals 1, 1 squared plus 2 is 3. So it goes through 1, 3. Also goes through negative 1, 3, 2, 5, and negative 2, 5. So I can connect the dots there. And just for time's sake, I probably won't graph every single function on my paper here, but I just want to kind of show you what you could be doing at home. So we've got these two functions. We started off with our blue function, and then we translated this into our red function here. So what happened? We went 2 units up, right? We started down here, and then to get to that red function, we shifted vertically up 2 units. All right, for part B, I'm going to clear these out. Y equals absolute value of x. Go into math, absolute value of x. And then y equals absolute value of x minus 3. So math, absolute value of x. Now make sure that you are out of your absolute value sign. So I use that right arrow key to get out. And then I'm going to type minus 3. And if you have an older calculator, it'll say y sub 2 equals ABS. You put your parentheses just around the x, so make sure the x is surrounded in parentheses, and then you type your minus 3 outside. Alright, let's see a graph of these. And you can use your trace key to identify points. To go ahead and plot these. So there's my y sub 1, and then my y sub 2. If I use my trace key, go down here, I can see that the corner is at 0, negative 3, that sharp corner. And I could use the trace function to identify other points, but this is what my transformed function would look like. So what just happened from the original to get to that red function? My function shifted 3 units down. Okay. So notice that in both of these cases, we're just attaching a constant to the edge, to the end of my function. So part C says determine without graphing. If we start with y equals x squared, how would you graph y equals x squared minus 4? So before, when we added a positive constant, we went up. If we subtracted a constant, we went down. Minus a constant, we went down. So minus 4 is going to create 4 units down. And if you want to check that, I know it says without a calculator, but I'm paranoid. Let's just double check. Y equals x squared versus y equals x squared minus 4. So we can see that red function shifted down 4 units from our original function. All right, part D, begin with the graph of y equals x squared. If your constant is positive, if c is greater than 0, how would you graph y equals x squared plus c? So we're going to be adding a positive constant, right? So maybe y equals x squared plus 5 or something. We would move up c units. And part E, begin with the graph of y equals x squared. If you have a positive constant, like 3 or 9 or whatever, how would you graph y equals x squared minus that constant? So maybe y equals x squared minus 5, and in that case we would be moving c units down.